But finally, there is the DART mission, which is about to show us whether or not we're better than the dinosaurs. All right? The dinosaurs didn't have a space program. They weren't able to deflect the asteroid, and they got pummeled. And then we took over. All right? So we don't want that happening to us. So the Double Asteroid Redirect Test, or DART, is an impactor spacecraft. I'm going to actually open this up here because one of the awesome tools that NASA has that's available to everybody is NASA's EYES. And NASA's EYES is like a 3D visual interpretation simulator of the different missions that they have. We followed that on the Perseverance mission, where we literally were watching it live. We even watched the beginning where it kind of like showed you what the landing on Mars was simulated, what they were expecting it to be. So you could actually see it with these high quality graphics. I mean, it's crazy. You could even travel the whole universe, go to different times and show through. But this one has the DART mission lined up. So we're going to pull that up. It's literally live. I'm recording this about 6. This is right now. It's 6:32 p.m. on September 17th. And so that's exactly the time that is on NASA's EYES here. So I'm just going to record my screen, and then we're going to go into NASA's EYES. So the DART mission, this is NASA's EYES. As you can see here, we can scroll out, we can rotate. And so it tells you more about the mission. So the launch was November 24th, 2021 on board a Falcon 9. It's an impactor. This is the binary asteroid Didymos and Dimorphos. And the DART mission will test whether a spacecraft impact could successfully deflect an asteroid on a collision course with Earth. So this is the actual Planetary Defense Coordination Office. So they are tasked with this kind of thing, and it was really interesting. Like a few years back, online, they have these like disaster scenarios of like what would happen if an asteroid impacted, and like what the damage would be, which is it was a crazy. A crazy thing to talk about without another option, right? If you don't have a solution for stopping the asteroid, everyone kind of looks around and goes, are we kidding? Like, what are we doing? We saw Bruce Willis do it with Ben Affleck. You know, like, come on. This is literally Deep Impact, right? This is literally things of sci-fi, and we don't have a plan. And so the DART mission is legitimately it's one of the longest game of billiards that we've ever seen, but literally that's what they're going to do. They're going to impact the spacecraft and see if the orbit of this dual asteroid system changes, and whether this kinetic impactor actually shows that we could deflect an asteroid. You know, if we see the asteroid soon enough and we hit it, we just don't need to hit it hard. We could just nudge it. We don't have to put a nuke inside of that thing and blow it up like they did in Armageddon. We just need to move it slightly at the right time, and it'll completely miss us. So I'm going to go to the DART mission website. And so the DART impact is planned for September 26th at 7:14 p.m. Eastern Time, and it's going to impact the moonlet Dimorphos, and that's going to try and put it in a new orbit a little tighter around Didymos. And one of the good things is that this was not ever actually something that we had to worry about impacting Earth. So it's a test, low stakes if it doesn't work. And so currently the orbital period of Dimorphos and Didymos is 11 hours and 55 minutes. And the separation between the two of the center of the asteroids is 1.18 kilometers or 0.73 miles. And the DART spacecraft will impact Dimorphos nearly head-on, shortening the time it takes the small asteroid moonlet to orbit Didymos by several minutes. So, great kinetic experiment. You know, it's like those two trains or two cars, that physics problem in high school coming together to hit each other, what's going to happen in the resulting force, right? So I'm really excited to see where this goes. It's a cool mission. I think this type of stuff makes this is where the money in space should be going to. Let's figure out this stuff, right? We are on a giant spacecraft called Earth, flying around the solar system that's in this whole galaxy, the Milky Way galaxy, that we still really know extremely little about. And we know from looking back in the history that a whole reign of other things, giant lizards, ruled this Earth, and they went down because an asteroid impacted. And we know there's a good chance that could happen again. So why not try and figure it out? I mean, right? I mean, yeah, we're going to the moon, but also it would be good to defend against this, okay? It would be really good to have a backup plan. So, DART mission, I'm super excited for that. And I don't know how big they would have to make another spacecraft if it was a really giant asteroid. But again, this is about like strategic implementation of a force, right? Like the 1-inch punch of Bruce Lee, right? Or like if you use the right application of force in the right place at the right time, you can change the entire course of humanity. So one of the coolest missions that we've had in space in a while, all around humanity surviving our place here in the universe, whether it's on Mars to help make moon travel, Mars travel, and life on Earth better, but also things like DART that could protect us from getting wiped off the planet completely. So, and even an option with Moxie to help cure the woes of climate change on our planet that we don't really have a good way of turning it around now. This is doing it on a totally different planet. So I don't know how big Moxie would have to be, probably bigger than a microwave or a toaster. But if we can get a few of those here on Earth, we could do some stuff. We can really change things. That's one of the great things about science. A lot of these missions are talking about, which is all these things that we thought were not possible. And a lot of the science and research is going towards, we did make it possible. Now, how useful is it going to be? What can we really do once we've proven that this is possible?